So we have the trigonometric function 1 plus cosine of x over 10 squared x. So we need to find its limiting value when x approaches pi. So we have limit x approaching pi 1 plus cosine of x. Now we have a tangent squared x in the denominator. We can use the identity that 1 plus tangent squared x is equals to secant squared x. So that means we'll have tangent squared x equals to secant squared x minus 1. So let us replace with secant squared x minus 1. So we have secant squared x minus 1 in the denominator. Now also the secant function is the reciprocal of the cosine function. So we'll have limit x approaching pi 1 plus cosine of x divided by 1 over cosine squared x minus 1. Now combining the two terms in the denominator, that is going to give us limit x approaching pi 1 plus cosine of x divided by 1 minus cos squared x divided by cos squared x. So we're going to take it to the numerator. So we have cosine squared x multiplied to the numerator. Limit x approaching pi 1 plus cosine of x multiplied to cos squared x. Now we have 1 minus cosine squared x, so 1 can be written as 1 squared. So that gives us the identity a squared minus b squared, which is simply the product of the sum and difference of a and b. So let us apply that, and this is going to give us 1 minus cosine of x multiplied to 1 plus cosine of x. So we can now factor out 1 plus cosine of x from both the numerator and the denominator, leaving us with cosine squared x in the numerator divided by 1 minus cosine of x in the denominator. Now let us substitute for the value of x. So we're going to get cosine squared pi over 1 minus cosine of pi. Now cos pi, the value of cosine of pi is equals to negative 1. So let's use this value. So we'll have negative 1 squared over 1 minus of negative 1. So this is going to give us plus 1. So we have 1 over 2. So this is going to be the limiting value of a given function when x tends to pi. Let us do another one. So we need to determine the limiting value of the given trigonometric function when x approaches pi over 4. Now here we're going to use the identity that 1 plus cot squared x is equals to cosec squared x. So let us substitute the value of cosec squared x into a given function. So we have limit x approaching pi over 4. So cosec squared x will become 1 plus cot squared x minus 2 divided by cot x minus 1. Limit x approaches pi over 4. So we have cot squared x minus 1 divided by cot of x minus 1. Now the 1 in the numerator can be also written as 1 squared, so that we have the identity a squared minus b squared, and that is going to give us limit x approaching pi over 4. So we have cot of x minus 1 multiplied to cot of x plus 1 divided by cot of x minus 1. Now we can cancel cot of x minus 1 from both the numerator and the denominator, and that is going to leave us with limit x tending to pi over 4. So we have cot of x plus 1. Now let us substitute the value of x. So we have cot of pi over 4 plus 1. Now cot of pi over 4 is 1. So we have 1 plus 1, which is equals to 2. So 2 is going to be the limiting value of the given function when x approaches pi over 4. Let us do another one. So we need to determine the limiting value of the given trigonometric function when x approaches pi over 6. So clearly when we do a direct substitution for the value of x into the given function, we are going to get an indeterminate form, which is 0 over 0. So that means we are going to need to do some simplification to the given function. So let us begin with cot squared x, because we have cot squared x is equals to cosec squared x minus 1. So let us substitute this value into the numerator. So we have limit x tending to pi over 6. So we have cosec squared x minus 1. So minus 1 and negative 3 will give us negative 4 divided by cosec x minus 2. Now we can also rewrite the 4. So 4 can be written as 2 squared. So that we have the identity a squared minus b squared in the numerator. So this is going to give us limit x tending to pi over 6. So we have cosec of x minus 2 times cosec of x plus 2 divided by cosec of x minus 2. So we can cancel out cosec of x minus 2 from both the numerator and the denominator, and that's going to leave us with cosec of x plus 2. So we have limit x approaching pi over 6 cosec of x plus 2. Now let us substitute this value of x. So we have cosec pi over 6 plus 2. Cosec pi over 6 is 2, so our final answer will be 4. So this is going to be the limiting value of the given function when x approaches pi over 6. Let us do another problem. So here we have the trigonometric function 2 minus cosec squared x divided by 1 minus cot of x. So we need to find the limiting value when x tends to pi over 4. So we're going to substitute cosec squared x cosec squared x by 1 plus cot squared x. So that is going to give us limit x approaches pi over 4 2 minus we have 1 plus cot squared x divided by 1 minus cot x. So that is going to give us the limit x approaching pi over 4. So we have 2 minus 1, so that will be 1, and we have a negative cot squared x divided by 1 minus cot of x. So we have 1 squared minus cot squared x in the numerator. So that becomes an identity which can be expanded as limit x tending to pi over 4 1 minus cot of x times 1 plus cot of x divided by 1 minus cot of x. So that is going to leave us with limit x tends to pi over 4 1 plus cot of x. So we have 1 plus cot of pi over 4. So cot of pi over 4 is 1. So that is going to give us 2. So 2 is going to be the limiting value of the given function when x approaches pi over 4. Let us do another. So here we have 1 plus cosec cubed x over cot squared x. So we are going to expand the numerator because it's in the form of a cubed plus b cubed, which is simply equals to a plus b times a squared minus ab plus b squared. So let us expand the numerator. So we have limit x approaching 3 pi over 2. So we have 1 plus cot cube x, so that will become 1 plus, we have 1 plus cosec cube x, so that will be 1 plus cosec of x times 1 squared, which will be now 1, minus a and b. So a is 1, so 1 multiplied to cosec x. So we have cosec x plus cosec squared x whole divided by cot squared x. Now cot squared x can be also written as cosec squared x minus 1. So we have limit x approaching 3 pi over 2, 1 plus cosec of x times 1 minus cosec of x plus cosec squared x whole divided by, so we have cosec squared x minus 1, so 1 can be written as 1 squared, so we have cosec of x minus 1, so this is an identity, times cosec of x plus 1. Now we can get rid of the cosec, oops, I made a mistake here, so this is cosec of x plus 1, so we can factor out cosec of x plus 1 from both the numerator and the denominator, and that is going to leave us with limit x tends to 3 pi over 2, so we have 1 minus cosec of x plus cosec squared x divided by cosec of x minus 1. Now let us substitute the value of x. So we have 1 minus cosec of 3 pi over 2 plus cosec squared 3 pi over 2 divided by cosec 3 pi over 2 minus 1. Now cosec of 3 pi over 2, cosec 3 pi over 2 can be also written as 3 pi over 2 plus 0. So this is going to give us secant of 0. Now since 3 pi over 2 plus 0 indicates that we are in the third quadrant where only the tangent function is positive, so that means we're going to get negative sec 0, and secant of 0 is 1, so the value of cosec 3 pi over 2 will be equals to negative 1. So this is going to give us 1 minus of negative 1, so we'll have positive 1 plus negative 1 squared will be 1 divided by negative 1 minus 1. So our final answer is going to be negative 3 over 2. So this is going to be the limiting value of the given function when x approaches 3 pi over 2. Let us go to the next question. So in this particular question, we need to determine the limiting value of the given function. So first we begin by simplifying the given function. So we have secant squared x, so that becomes 1 over cosine squared x minus 2 times tangent of x is simply the ratio of sine over cosine divided by 1 plus cosine of 4x. Now we have the identity, 1 plus cosine of 2 of x is equals to 2 times cos squared x. So 1 plus cosine of 4x will become equals to 2 times cosine squared of 2x. So we have 2 times cosine squared 2x in the denominator. Now combining the two terms in the numerator is going to give us 1 minus 2 times sine of x times cosine of x divided by the cosine squared x. So the cosine squared x comes to the denominator, so we have cosine squared x multiplied to 2 times cos squared 2x. Now we have the identity cos squared x plus sine squared x equals to 1, so we have replaced the 1 in the numerator by the identity. So we have negative 2 sine x times cosine of x divided by 2 times cos squared x times cosine squared 2x. Now cosine squared 2x, cosine of 2x, This is equals to cosine squared x minus sine squared x. So we have cosine squared x minus sine squared x whole squared in the denominator. Now this gives us an identity which is a squared plus b squared minus of 2 times a and b in the numerator. So that means the numerator is simply cosine of x minus sine of x whole squared divided by 2 times sine squared x. Now we have a squared minus b squared in the denominator, so that can be expressed as the sum and the product of cosine of x and sine of x. So we have cosine of x minus sine of x times cosine of x plus sine of x whole squared. So when we get rid of the square in the sense, like this can be rewritten as whole squared times whole squared so now we can get rid of the cosine of x minus sine of x whole squared from both the numerator and the denominator, and that finally leaves us with 1 over 2 times cos squared x multiplied to cosine of x plus sine of x whole squared. So this is the simplified form of the given function. Now we are going to apply the limits. So we have 1 over 2 times cosine of pi over 4, which is 1 over square root of 2 whole squared times cosine of pi over 4 is 1 over root 2 plus sine pi over 4, which is also 1 over root 2 whole squared. So that gives us 1 over 2 times half times 2 over root 2 whole squared, and this is going to give us 1 over 2. So this is going to be the limiting value of the given function when x approaches pi over 4.